Hello everyone, I hope that you all are doing great. This is the second video of the chemistry series on this YouTube channel. In the first video, we discussed about chemistry. It was an introductory video in which we discussed about the basic fundamentals of chemistry. And now in this video, we are going to discuss about a single topic, and that is going to be atomic structure. So this, if you have not watched the first video, I would highly encourage you to pause this one and first go ahead watch that video. And I'll put the links in the description and on the I button so you can easily find that. And in case you don't know, my name is Alisha Jindani and I will be guiding you. I will be teaching you chemistry throughout this series of videos. So without any further delay, let us get started. So before studying about atoms, before studying about atomic structure, we have to first study about atoms. What are atoms? We also discussed this previously and I'm going to discuss it once again. What are atoms? Now, first thing that you need to know, chemistry is all about matter and particles. So all of matter, all of the things that are around us, they are made up of particles. The particles are very tiny, very small, and atoms are one of those particles. Now, what makes an atom stand out from the rest of the particles is that it is the smallest of all particles that can exist and that cannot further be broken down chemically, right? So atoms, you cannot break them down, you cannot react them, and you cannot get two atoms out of one, because that doesn't work like that, right? The atom is the smallest part of all particles that you cannot further break down, and everything around us is made up of atoms. Atoms are the ones that form elements, that form compounds, and that form mixtures as well. And if you remember from the last video, let me show you. Here we had discussed about all of the matter. So here you can see that everything, this element, this compound, this mixture, okay, everything, in all of them we have got atoms. These circles are atoms, and they can form elements with single atoms, compound with double atoms bonded together, homogeneous mixtures, and heterogeneous mixtures as well. So yeah, that was a short kind of image from the last video. Coming back to today's video, this is atoms, right? Atoms are the tiniest of all things and they make up everything around us. Now, if we talk about the atoms, this is a very simple diagram of an atom. As you can see, we are going to go more into depth about atoms right now. So the first thing that we are going to discuss is the structure of an atom. The structure of an atom. So atoms, they are the tiniest of all particles, but they are also composed of even more tinier things that are known as subatomic particles, right? Subatomic particles. And these subatomic particles are protons, neutrons, and electrons. Again, we are further going to discuss about all three of these individually. And another thing that you need to know about atom is that every atom is electrically neutral, which means that it has the same number of protons and electrons. Now, this diagram, okay? So here you can see we have got an atom, and you can see these red dots, they are the neutrons, the plus signs are protons, and the negative signs are electrons. Okay, so you can see here that we have got the protons and the neutrons smushed together into the center of the atom, and this part of the atom we call the nucleus. Here you can see we call it nucleus, which has 6 protons and 6 electrons. You can count them. And finally, we have 6 electrons orbiting this nucleus. They are going around the nucleus in these kind of rings, kind of orbits. You can also call them shells. So this is a shell. This is an electronic shell, the blue lines, right? So this is the very basic structure of an atom. Obviously, it can go much more deep, much more advanced, much more deeper. You can obviously go like that. But this is the very basic structure of an atom which you should know about. So that is it for the structure of an atom. Now if we talk about protons, neutrons and electrons, I told you we are going to talk about them. So a proton is positively charged, which means we usually denote it with a 1 plus, 2 plus, 3 plus. So always we denote it with a positive sign. A neutron is electrically neutral. Electrically neutral means that it is uncharged, which we usually write as a zero charge. And the electrons are negatively charged. So we use a negative sign to denote that these are electrons. Here you can see a short table which contains the differences between protons, electrons and neutrons. Now you can see that the proton, it carries a positive charge, it has a mass of 1 and it is located inside the nucleus, right? Now again mass, we are going to discuss about that as well. The neutron, a zero charge and it is also located in the nucleus. The electron, negative charge and it is located in the orbitals, in the shells, you can call it whatever you like, right? Now talking about the mass of the subatomic particles. Now almost all of the mass of the atom is located inside of its nucleus, right? And we discussed earlier that the nucleus is made up of protons and neutrons. That means that most of the mass of the atom is present in its protons and in its neutrons. Now again, I'm not saying that electrons do not have mass at all, right? Electrons do have a very tiny mass and we often consider it as negligible. Why do we consider it as negligible? Is because you don't have to count them in your calculations. It is very tiny fraction of, as compared to the protons and the neutrons. So usually we write the protonic mass as 1, neutrons mass as 1, and for the electrons we take a 0, although it is not a 0, right? So this is again another thing you should know, that the mass is made up of protons and electrons, which means protons and neutrons, which means most of the mass of the atom is located inside the nucleus. And that is the reason why the electrons are orbiting the nucleus, right? So this is the very things that you need to know. Now some more things I'm going to tell you about are the key definitions. So these you will hear a lot, so I decided to put them together to make it easier for you. And we first have the atomic number, or you can also call it the proton number, and as the name explains, it is the number of protons inside of an atom. But what's important about this thing is that this is pretty much related to the periodic table as well. We discussed about the periodic table in the last video and we are going to discuss about it once again. So here you can see, I told you in the last video that we have these numbers, these unique numbers 1, 2, 3, 4 and so on, that are increasing from left to right and from top to bottom as you go along the table. And these numbers are unique for each atom. So there is no other element that contains one proton, right? These are the proton numbers. So here you can see that these are unique for every element, which means that these can be used to identify an element, right? So always the atomic number is used to uniquely identify an element. So if there is a one atomic number, you always are going to know it must be hydrogen, right? Similarly, 2 must be lithium. So this is the very key number that all atoms should have, right? Now another thing that we have is the neutron number, the number of neutrons inside of an atom, right? Pretty simple. So the neutron number is not given in the periodic table. Don't confuse it with this number. Let me show you. Don't confuse it with this number below. This is the next one. This is the atomic mass, which we are going to discuss now. So the third thing is the nucleon number. The nucleon number aka the atomic mass, or we also denote it with the symbol AR. So this is the total number of nucleons. Now you might ask, what is a nucleon? So a nucleon is anything that is part of the nucleus, right? Don't confuse it with neutron. Neutron is this red kind of thing, but the nucleons are all of them. So the nucleons, protons are also nucleons, right? So that is what you need to know. Here we have the total number of nucleons, that is the subatomic particles inside of the nucleus, which are protons and neutrons that are present inside an atom, right? So basically it is the sum of the protons and the neutrons. So for instance, if I want to find the number, so if I, let's say I take carbon in the periodic table, let me zoom it down, zoom it further. So if I take carbon in the periodic table, here you can see that carbon has an atomic number. I can denote it as a proton number as well. It has 6 protons. And if you look at this mass, so the AR, or you can also call it the mass, that is 12. So what if I want to find the number of nucleons? What do I have to do? I have to subtract. So I will subtract 6 from 12. So I get 12 minus 6, right? And we get a 6. So we know that the number of neutrons in this atom is 6, right? Pretty simple. So basically the atomic number, so if you combine these two, let me zoom it down again. So when you add this and this, when you add, the sum is equal to this. That is the very simple thing that you should know. And again, I'm going to remind you that if we want to find out the number of electrons inside this carbon, well, it is simple. It is the same as the protons. Why? Because if you look at it, we have 6 positive charges inside of carbon, which are the protons. We have 6 zero charges, which are the neutrons. I'm just going to write it like that. It's not proper notation, but, and you can see we must have a zero charge. So how do we have a zero charge? We must have 6 electrons, so that the protons and the electrons cancel out and we are left with a zero charge. So that is why electrons, because an atom is electrically neutral, that means that you must have the same number of protons and electrons in an atom. So that's how you find out all 3 of these using the periodic table. The next thing that we are going to discuss is the isotopes. Now, isotopes are basically atoms of the same element, but there is a very tiny difference. So what do we mean by same element? Remember, I told you that every element is identified by its proton number, which means that if you have the same element, it means it has to have the same number of protons, right? Simple. And if it is the same element, it has the same number of protons, then what is different about isotopes? It is the number of neutrons, right? So isotopes are basically identified or denoted by their mass. So like the primary identification of an atom is your proton number, and in case you have any isotopes of that element, we are going to write the atomic mass, like carbon 14, which tells us that this carbon does not have 12, it has 14 of atomic mass. Similarly, uranium 235. So these are kind of the isotopes. So again, we discussed right now about the carbon 12, because this has a mass of 12, but we also have a carbon 14, and we can work out the proton number. We have the proton number, that is 6, and we can work out the number of neutrons by subtracting 6 from 14, and we get 8, and electrons 6, right? So that is how you deal with isotopes. Carbon has carbon 12, carbon 13, carbon 14, and we also have isotopes of hydrogen. So hydrogen has, like, there are names of the isotopes of hydrogen as well. So there is tritium, that is hydrogen 3, we have a hydrogen 1, a hydrogen 2. Now all of the isotopes cannot be listed in the periodic table. So we have to pick one isotope, we pick one isotope and we list it down in the periodic table, and the one that is present in the periodic table is the most common one that is found in nature, right? So we see hydrogen 1 a lot in the nature, we see carbon 12 a lot, that is why we put them in the periodic table, but that does not mean that only carbon 12 exists, carbon 13 also exists, carbon 14 also exists. So these are isotopes. Another topic that is pretty much related to isotopes is radioactivity. Now that is a topic for a physics class, obviously, because it is more linked towards, more inclined towards physics. But you need to know that some isotopes basically, radiate, they emit particles, and hence, they are called radioactive, right? This carbon 14 is radioactive. Others also are present, but again, we are not going to go much deep into that topic right now. Let's leave it for a later video. Okay. So now that we have discussed about atoms, we have discussed about isotopes, we have discussed about protons, neutrons, electrons. So we have our basics covered. Now we are going to do a little bit of an advanced topic. Again, it is not difficult at all. It is pretty easy, but it is a advanced topic. This is electronic structure. So every atom has electrons, right, which are arranged in shells around the nucleus, as we discussed earlier, right? So every again, I'm going to show you that picture. So these are the shells. Let me choose a different color. This is a shell, this blue line, this is a shell, and the electrons are present inside of these two shells around the nucleus. So basically this is the first line. Now this is the basic thing. Now we are talking about the electronic structure. The electronic structure is the arrangement of electrons in the atom. So in very simple terms, it is like I'm asking you how many electrons are in the first shell, how many electrons are in the second shell, and so on. So this is known as the electronic structure, the arrangement of electrons. It is also sometimes known as the electron configuration as well. So this we are going to discuss right now, and it is a more like a calculation kind of thing. So also we need to know that each of the shells can hold a certain amount of electrons. That means that every shell cannot contain the same amount of electrons. It varies, and I'm going to tell you about that as well. And the last thing that we need to know is that the period of the atom tells the number of shells, and the group tells the number of atoms in the last shell. Again, it might be a little bit unclear, so I'm going to do it on the period near the periodic table. Let us first clear this thing up. So we are going to erase everything right now, and we are going to talk about electronic configuration or electronic structure. So we are done with that. Now let us again zoom in a little bit, and let's find the electronic configuration for sodium. So first things first, what I'm asking you about is how many electrons are in the first shell of sodium, how many in the second, how many in the third, and as many shells sodium has, how many electrons are in each of the electronic shells. So the very simple process, first you are going to note down the period number. I told you that the rows of the periodic table are known as periods, whereas the columns are known as the groups. So you are first going to note down the period number. Let me clear this up. So first we are going to note down the period number. We are going to write P, that is 3, right? So the period number of the sodium atom is 3 and the group number is 1. So we're going to write G is 1, right? Now, the next thing that you need to note down is this number. I told you that this is the number of protons, and since the number of protons and electrons are same, we know that the number of electrons in this sodium atom or in this sodium element is 11, right? So this is the very basic data that you need to have. Now, always remember that first you are going to take a look at this P, okay? You can see that the period number is 3. So what you are going to do, you are going to put 3 blanks, right? 3 blanks, 1, 2 and 3 separated by dots. So I know it looks like Morse code, but it isn't, okay? So again, that is what you need to do with the period number. You are going to put 3 blanks and you are going to separate them by dots. Now comes the group number. The group number, basically what you are going to do, you are going to take this number, that is 1, and you are going to put it in the end. So group number, I told you, it tells us the number of electrons in the last shell. So the last shell we now know. And now we have 11 electrons in this atom. So we know that the total of all 3 of these has to be 11, right? Now, another thing that I'm going to tell you is the number of electrons each shell can hold. So the first shell can hold 2 electrons, the second shell can hold 8 electrons, third one can hold 18, fourth 32, and it goes on, right? Again, there are many more, but we are doing the basics, so we are not going to go any further. So you can see here is an 11. So what you have to do, you have to first fill in a 2 and an 8. And if you do that, you actually notice that you are done. Now there was another step which did not come up, which we have to do in most cases, and I'm going to explain to you about that as well. So this, now you can see these add up to 2 plus 8 is 10 plus 1 is 11. So if anyone asks you how many electrons in the first shell of sodium, you can say 2, in the second shell 8, in the third shell 1. And I've got is this diagram for you as well, which shows this electronic structure of sodium. So here you can see that in the first shell we have this, in the second 1, 2, 3, 4, 5, 6, 7 and 8, and in the third we have 1. So this is the electronic structure. You can use commas to separate it, you can use dots, it's up to you. But that is how you find out the electronic structure. Now we are going to do one more example for the sake of clarity, so that you don't have any doubts. We are going to use this element iodine, and we are going to find out the electronic structure or the electronic configuration. So again, first what you are going to do, you are going to note down the period number. If you see here, we have the period number of 5 and the group number. Now again, I don't know if I told you this thing or not, but the first group is this one, this guy is the second group, this is the third group, this is the fourth, fifth, sixth, seventh, and this is called group 8 or group 0. These central elements don't have any sort of group, although you can see in this periodic table, but usually they don't have a particular proper group, right? So these are the main groups. This is 1, 2, and iodine is found in the iodine is found in the 7th group. So we are going to write the period number is 5, the group number is 7, and we have the number of electrons, and that is going to be the number of protons, which is 53. So the first thing that I told you, you are going to look at the period number and you are going to know how many shells are there. So we've got 5 shells. We're going to put 5 blanks over here, right? Now the second thing that you need to do, you are going to look at the group number. You're going to look at the group number, that is 7. So this tells you that the last shell has how many? 7 electrons. And now if you look, the total number of electrons is 53. If you take 53, you subtract 7, you get 46, right? So we are left with 46 electrons. Now the first thing that you have to do, if you look at here, we already know that this is the basic method. So we have got, these are the limits, these are the maximum number of electrons that every shell can fit. But what we are going to do, we are going to do it like this. So we are going to 2, 8, 8, 8. Now you might ask why we take 8. That is because every shell does not have to fulfill its requirement. So if this shell can hold 18, it does not have to hold 18. It can hold 18. It's up to that atom, right? So again, what we are going to do, we have got 8, 8, 16 and 8, 24 and 26. So we are done with 26 more, right? Now when we subtract again, we get another 20. So we have to fit in another 20, and here is when the limit comes into play, right? So what we are going to do now, we are going to add. So if we look at this one, we have the limit of 2, 8, 18, 32. So we are going to look at this, and we know that this shell is full, right? It cannot hold more than 2 electrons. This shell is also full. This is not full, this is not full, and we don't deal with the last shell. We just leave it for now because last shell is totally fixed, right? This is also fixed. Now what we can do, we can add electrons to these two shells. So this one, I told you, this can hold up to 18 electrons. So we are going to fill it up, and we subtract another 10, and we get another 10 to work with, and so we are going to put another 18. So this also becomes 2, 8, 18, 18, 7. And here you can see I've got this diagram again, and we have got iodine 2, 8, 18, 18, 7. And these are the electrons. Obviously we are not going to count them because it is going to take forever. So this is the structure of iodine. You can see the last shell has 7, the first shell has 2, and yeah, that is pretty much it. So this was, it took a little long to explain this topic, I told you. And this was electronic structure, a very, kind of important topic, but at the same time, very easy topic to learn. And now we come to the final topic of the day. So now we are going to talk about metals and non-metals. So the elements of the periodic table, as we discussed, are split into two main types, and these two types are metals and non-metals. So we are going to discuss the difference between them, but before we do that, let me tell you where the atoms are located and where the non-atoms are located in the periodic table. So again, let me zoom, and here you can see, actually let me zoom out a little. Yeah, here you can see in the very bottom of the screen the alkali metal, the alkali metal. You can see all sorts of metals, and you can also see the non-metals. So these are all metals. This is a non-metal, this is a metalloid. Now what, very basically, I can draw this line for you. So this line, so all of these that are left of this line, so let me draw it like this, right? All of the elements that are towards the left of this line, they are metals. So we can just, all of these are metals, right? So metals make up a very large portion of the periodic table. Next, if you look over here, we have got some elements that are of this color, and these are the metalloids. So you can see boron, silicon, arsenic, antimony, germanium. These are metalloids. And metalloids, basically I'm going to tell you about them as well. And on the right side of this line we have got the non-metals. So again, non-metals make up a very small portion of the periodic table compared to the metals. Now what is the difference, you might ask? So let's go back to our slide. And so I told you about metalloids. Metalloids are like mixture of metal, like not mixture, but it's rather like they possess some of the properties of metals and some of the properties of non-metals, right? So let us discuss about the major differences, because if we are going to talk about metalloids, obviously we will be overcomplicating things for no good. So we're not going to discuss about metalloids right now. We are just going to do a general overview of the metals and the non-metals. So we have metals, they have shiny appearance, whereas non-metals have a dull appearance. Here I have picked a picture for you, and here you can see this is probably gold, this is bronze, this is silver, these are some other metals as well, and they are pretty much shiny, right? You can see that they are glowing, they are shining. Whereas if you look at these non-metals, so there is sulfur, there is carbon, there is red phosphorus, they are not as shiny compared to those metals, right? Now, the next thing that you need to know, metals are good conductors. Good conductors of what? Heat and electricity. Whereas the non-metals are not good conductors, rather they are good insulators, right? So metals, they can conduct electricity, they can let heat pass through them. That is why we call them good conductors. Another thing about metals is that they have high melting and boiling points. So the melting point is basically the temperature at which an element melts, and the boiling point is the temperature when an element boils, right? So they are basically and this property makes them solid at room temperature. If we talk about non-metals, they have lower melting and boiling points, which means mostly they are gases at room temperature. Now, metals have high density. Metals have high density, whereas non-metals have low density. What does that mean? Metals feel heavier. Metal feels heavier compared to the non-metals. Then we can talk about malleability. So metals are malleable, which means they can be made into shapes, into different shapes. Here you can see the metals have been made into cube shapes, right? Whereas the non-metals are brittle, so they can break up pretty easily. You can see here they are in pretty much, the carbon is in powdered form, the sulfur broken up into pieces, so they pretty easily break up. The metals again are ductile, which means they can be drawn into wires, and a very good example is copper. So we get a lot of copper wires, and why do we get a lot of copper wires? Because it is ductile, because it conducts electricity. So it's a very good thing and a very cheap thing for making wires. And we also have the last property, that is sonorous. They are sonorous, which means when you strike the metals, they make a ringing sound. So these are the major differences between metals and non-metals, and they are mostly their physical differences, although there are many other chemical differences as well. Like metals form positive ions, non-metals form negative ions. Metal make up basic oxides, non-metal make up acidic oxides. So a lot of other differences as well, but I did not put them up right now because obviously we have not studied everything in chemistry, so that is going to be a little bit more confusing for you. So these are the major differences, the very physical, that you can pretty much relate to in daily life. These are the differences. And with that said, I think our today's video comes to an end. So we discussed about metals and non-metals, we discussed about electronic structure, isotopes, and a little bit about radioactivity as well, the definitions. So we are pretty much done with everything. And yeah, so we are done with everything, and it's time to end the video now. So again, I hope that you enjoyed watching this video. I pretty much enjoyed making it, and this was the second part. Again, if you have not watched the first part, you can go ahead, check that out. You can check out other videos on my YouTube channel as well. And yeah, that is pretty much it. In the next video, we are going to talk about atomic bonding. So we're going to talk about ionic bonding, covalent bonding, and metallic bonding. So you can stay tuned for that and keep watching and keep enjoying the videos. I hope that you like this video. And yeah, that is it. If you want to support me, you can go ahead, like this video, share it with your friends, and subscribe to the YouTube channel, which would be much appreciated. And yeah, I will see you in the next one. Till then, take care and bye bye.